Pro and Max subscribers running intensive tasks often hit a wall, a hard 5-hour usage lockout, right when they need the compute most. The immediate assumption is that asking too many questions drains the quota, but the math points elsewhere. The drain comes from highly inefficient context window management and a basic misunderstanding of how the system allocates compute. In April 2026, Anthropic released Claude Opus 4.7. Without much fanfare, this update integrated a new, automated architectural layer designed to manage resource burn. This layer introduced adaptive compute. It shifted the AI away from a flat-rate inference model to a variable-rate engine that adjusts power based on the task. By aligning our daily workflows with this new adaptive architecture, we can mathematically double or even triple the net output capacity of a standard subscription. We need to map exactly how Claude Opus 4.7 routes internal compute, and then establish a strict protocol for token optimization. Treating Claude as a simple conversational chat app guarantees rapid quota depletion. Maximizing output requires operating it as a dynamic inference engine. Older models applied a static, flat-rate block of compute to every prompt. Asking for the day of the week consumed nearly the same logic resources as analyzing a legal contract. The Opus 4.7 update replaced this with a system called adaptive thinking. The model now autonomously evaluates the complexity of a query before it allocates any processing power. This diagram illustrates the architectural efficiency difference. The old static processing dropped maximum compute on every input. On the right, variable block sizes now dynamically scale to match the incoming data. For simple queries, it bypasses deep internal reasoning loops entirely, generating immediate, low-token output. When a highly complex prompt arrives, the system scales up, exclusively reserving heavy reasoning loops and maximum compute power for tasks that require deep analysis. Output length is also dynamically clamped. The AI evaluates the request and delivers a concise answer, eliminating the long-winded, multi-paragraph explanations that characterized earlier versions. But the adaptive triage has a failure state. Occasionally, the model will misclassify a crucial complex prompt as a simple one, resulting in a shallow, unhelpful response. We can overwrite this by embedding explicit semantic triggers directly into the prompt. Commanding the model to deeply analyze or provide comprehensive arguments forces it into deep inference mode. This guarantees a thorough initial pass and prevents the need to spend additional tokens on corrective follow-up questions. Understanding this triage logic prevents us from paying heavy compute prices for lightweight tasks, while ensuring the maximum processing power is activated when accuracy is critical. Context V-calculation consumes more tokens in Claude Opus 4.7 than the generation of new text. When evaluating a saturated context window, the system must recalculate the entire prompt history to understand the relationship between the latest message and everything said prior. This animation shows the compounding cost of a conversational thread. Every single new input forces the model to rescan and reprocess the complete historical stack. By the 20th conversational turn, efficiency drops to near zero. The compute quota is burning entirely on rereading old data just to process a single new line of text. The first defense against this penalty is aggressive context pruning. We achieve this by frequently opening new, blank threads. The moment a specific task is resolved or the topic shifts, clearing the context cache is mandatory. This immediately stops the exponential token bleed. The second protocol is prompt consolidation. Instead of feeding the model a sequence of questions, identifying a bug, proposing a fix, and analyzing the performance impact, combine all related parameters into a single, structured, multi-part prompt. Standard, line-by-line conversational prompting is mathematically resource inefficient. Rigid context pruning and consolidating instructions are the primary ways to defend your compute quota. There is a persistent fallacy among power users that paying for the max tier means Opus 4.7 should be the default engine for every single interaction. This leads to massive overexpenditure. We counter this with a step-up routing protocol. This flowchart maps out the optimal query progression. Routine prompts route to haiku, moderate logic moves to sonnet, and only the most complex logic activates Opus 4.7. By running initial prompt tests and simple factual checks on Haiku or Sonnet, we can reserve the heavy, expensive Opus architecture strictly for deep logic execution or multi-step analysis. Another massive inefficiency is redundant data injection, manually pasting the exact same background documentation into every new chat thread. Anthropic built the projects feature to solve this, acting as a persistent document caching mechanism. This caching restructures how static reference materials, like API documentation or legal files, are built. Because the system caches these locked documents, users are only billed for the specific tokens generated during the query. It entirely eliminates the heavy cost of uploading the same background context repeatedly. Enabling the background memory and search functions further automates this process, allowing the AI to recall previous preferences and facts without requiring explicit, token-heavy explanations in every new session. Offloading static data to cached projects and routing simple tasks to lighter models systematically isolates the Opus 4.7 quota, saving it exclusively for high-leverage computation. The ultimate efficiency metric for Claude Opus 4.7 is zero-shot efficacy, securing the exact, precise answer on the very first attempt. This graph illustrates the comparative resource drain. Iterative, multi-turn debugging burns tokens at an accelerating rate, while a single, heavily engineered prompt requires just a fraction of the compute overhead. Because Opus 4.7 demonstrates a threefold reduction in tool error rates compared to previous versions, engineering one perfect, highly detailed prompt is mathematically 10 times cheaper than relying on iterative trial-and-error debugging. There is one final, uncontrollable infrastructure constraint that affects token efficiency: the physical server load. Global API traffic peaks heavily during standard United States business hours. This peak load causes model slowdowns, sudden timeout errors, and wasted tokens from aborted generations. Scheduling massive batch processing or highly complex workflows during low-load windows, specifically between 5 a.m. and 4 p.m. Taiwan time, minimizes error rates and maintains computational flow. Mastering Opus 4.7 requires replacing standard chatbot habits with a precise data architecture that treats compute as a high-leverage resource.